building higher than 24 is not allowed to use any structure. But that's, you are allowed some liberation. So just something that you all need to know. Otherwise, I'm going to go out very, very soon. Thank you very much.
Thank you.
Are we keeping the VR?
NYP Team 4. Okay, we welcome NYP Team 4 from Nanyang Poly.
Good afternoon, judges. I'm Zheng Long, and this is Neil. We collaborated with students from Taiwan, from the National United University and Chaoyang University. Yeah. Each member had a unique role in our group. So we had civil engineering student and an interior designing student. The rest of us are architecture students. Yeah. So about sustainability, as you can see from the diagram above, we understand that a building can only be truly sustainable when it fulfills all three requirements: the social, economic, and environment requirements. We'll elaborate that further later. So with that in mind, with that in mind, we started brainstorming. As this year's theme was touching the earth lightly, we thought that the development should therefore be designed to coexist with nature, minimizing the impact caused typically by the built environment. So in the design, a balance is struck between these two contrasting environments, like how we saw the trees and the vines coexisting at site. We realized that everything in the ecosystem is interdependent on each other. So leading to our answer to this theme, symbiosis. Symbiosis is a positive word, unlike the word parasitic. In order to ensure that the development turns out well, we went down to the site and had site analysis. This was the the human, the way they walk, and this is the sea breeze and land breeze, the sun path, and the general landscape. Qualities of the site were strong winds and greenery. Therefore, we thought that our site had to complement these qualities in order to achieve symbiosis. If not addressed properly, the development may end up being parasitic, doing more harm than good to the site. The design was hence steered to capitalizing these qualities. To develop a design that encourages flow in the design, inviting natural elements and people into our development, which is shown in this, where we bring in the greenery from the surrounding areas and the wind. I'll pass the mic to Neil.
So also part of a concept design process is to take consideration potential relationship between the architecture, PDD, which is the Punggol Digital District project. This helps us discover how to connect the project, the relationship, not just to the surrounding area of what site we're building at. Also trying to have a seamless transition to the PDD and the proposed building. So this idea we have decided to categorize it into a more detailed space planning, which is like to differentiate the fun, leisure, and workspace and into groups in our building. This one we can identify the perfect user circulation that will reduce the potential disruption to natural environment. So like jumping here, we have the retail and cafe and the library really close to the entrances from the west entrance and the east entrances of the site, because we actually want to have a crowd control traffic for the users, because we are expecting it to be more of public use and for fun. So we are trying to maximize the function. So our groups actually concluded that with this approach, we can provide a conducive place for the creatures to inhabit and coexist to the space and share the space.
Okay, so with this diagram, I'm going to explain the standardized modules, DFMA approach that we use. So basically, it's essentially made out of two modules, Type A and Type B modules. The darker one, the one with the darker shade, is a Type A module, and the one with the lighter shade is the Type B module. It's essentially they're designed using the same language, and only the size was the difference. The use of these modules made designing flexible, and we can design an organically shaped building that represents flow, which was quite prevalent in our concept, by playing with angles and orientation of each module. And in order to facilitate air movement and concept of our building, which was unobstructed flow of greenery, wind, and people, the dotted lines represents the subtraction of modules in the area, breaking up the architecture. As prevailing wind from the site comes from the northeast direction, a gap was opened on purpose to take advantage of the wind.
So yeah, now we're gonna jump into the how we are trying to make it like lean and sustainable. So like to talk about the lean and sustainability of it, we actually like had the fly ash concrete as our like one main material, one base material for the building, and for building our architecture. We have put it into consideration because like we have kind of discovered that it's the more cost effective and less permeable, most permeable, less permeable type of concrete than Portland. So it has a higher water retention, and discover also that we have like a lesser heat of hydration. So we're trying to like have the building produce more heat than it could possibly have because of the weather in Singapore. And for this one, we have an example of the modules that we're gonna use. This is like the meeting room, small, medium, and large one, and essentially it's just a duplication of the units. So basically we're just using like one kind of module, but it has two types. Yeah.
Yeah, I'll continue with the project schedule. For the project, to do the project schedule, we use Microsoft Project. We inputted the different tasks that we had to take on. It's in the report, and yeah, in detail as it's a bit too small to see here. Okay, so with the help of our civil engineering students, we actually managed to create this table. So with DFMA approach, site work and production of modules can go concurrently. So all in all, it shortens up the construction entire process of it. And yeah, with this software, we are able to keep everyone on the same page so everyone knows their roles and responsibilities in this project. Therefore improving efficiency and reducing the chances of errors.
So we also use the software ISV for just to get basic information about like the external conduction gain of the building. It's not really very detailed, but like we actually divided it into five buildings for the analysis, and we have concluded that we can actually like apply a few solar panels on some places of the roof, and this is the wind analysis, the velocity of it. So we actually have like we've run 3 tests, and this is like the outline model of the proposed building, and we have kind of divided it into different levels. And as you can see, it's like that we have the impact of the architecture to the velocity of the air is like greatly reduced, and actually we're trying to stick true to the concept that we have. Yeah, and so this is like the final one, which is like just less impact to the velocity.
Basically, this is the use of AR technology, which we have a target image and an app in your phone. You can actually display this. Maybe we can show it to you guys afterwards.
So lastly, we have also used the VR because actually it's not good yet. So to get hold of the virtual experience of how the building is going to be like. And with this, we can actually conclude that the form of our design is achieving the symbiotic circulations that we have discussed in our group and identify the potential constraints that we might face.
Then is the use of technology and innovation, such as Revit models to detect clashes when, yeah. This is our final model. In summary, we thought that it's good that we embarked on this project as aspiring architects. Yeah, this project is not all about design, and we had many other things to think about. So collaboration with international students was also a very good experience, as we believe that in this globalized age, connecting has never been easier. So we as youth have the opportunity to work with one another, to learn, to grow, and to give, not just to our respective countries, but to the world. Yeah, thank you. Yeah, so basically, first we did it in a circle, and after that we break it into 16 parts. Then after that, each of the parts, believe it can be precast.